Hello there, ladies and gentlemen, and welcome to Lesson 3, Sedimentary Rocks. We're still here in Unit 3, Earth's Materials. We've knocked out minerals with Lesson 1. We slayed igneous rocks with Lesson 2. Now we're going to move on to sedimentary rocks here in Lesson 3. The video topics that we're going to cover: 1. We're going to review the definition of a rock with respects to sedimentary rocks. So we're going to see how sedimentary rocks fit into our overarching definition for a rock. That's the first thing that we're going to examine. The second video topic is a very large and broad topic because we're going to talk about the types and formation of each sedimentary rock. Those three types being detrital sedimentary rocks, chemical sedimentary rocks, and biochemical sedimentary rocks. Detrital is going to be the long explanation that we have. They're kind of considered like your classic sedimentary rock. Like when you talk sedimentary rocks, you're pretty much talking detrital sedimentary rocks. But we've got those other two thrown in there that we got to go ahead and we've got to acknowledge. All right. But the second video topic is going to be pretty large, pretty broad. But that's what we're looking at in this video. And without further ado, let's jump right in to topic number 1. Our definition for a rock from Lesson 2 is a naturally forming mixture, typically of rock fragments, minerals, or volcanic glass, that's bound together. Okay? Sedimentary rocks are rocks that form from the consolidation of rock particles or the crystallization from a solution. Okay? Now, when we're talking sedimentary rocks and we're talking about the consolidation of rock particles, we are talking about the consolidation of what we call clasts. All right? Clasts and detritus and sediments are three terms that all mean the same thing: tiny little particles of rock or mineral. So anytime we're talking about rock fragments and mineral fragments, we're talking about sediments, detritus, or clasts. Okay? Anytime you see one of those three terms, it's talking about the same thing. Alrighty? I'm going to use all three. So you got to stick with me. You got to keep up here, because I might mention or refer to them once as clasts, once as detritus, the next time as sediments. All right? So sedimentary rocks are rocks that form from the compaction and cementation, the consolidation, the binding together of clasts or sediments. All right? Or we've got the crystallization of some minerals that then bond or bind or hold together clasts. All right, due through the precipitation. All right, the forming of a solid from a liquid, like we talked about in Lesson 1 with minerals. Okay, so two major ways there that those sedimentary rocks can form. And again, we're talking formation when we're actually defining a type of rock. All right. So in review here with video topic number 1, our definition of a rock. Our overarching definition, okay, any naturally forming mixture from rock fragments, minerals, volcanic glass, that's bound together. And a sedimentary rock is a rock that's formed from the consolidation of rock fragments or mineral fragments, clasts, okay, or the consolidation of those fragments through the crystallization of a solution. All right? Set with that? Are you good? If you're not good, make sure you email me or contact me, okay? On to video topic number 2. The types and formation of sedimentary rocks. The first one we're going to examine, detrital sedimentary rocks. And like I said at the beginning, this is your classic sedimentary rock example here, okay? When common individuals are talking sedimentary rocks, they're talking detrital sedimentary rocks. It's the most famous, all right? It's the Justin Bieber, the Lady Gaga, the Katy Perry of sedimentary rocks. Detrital sedimentary rocks. It also has the classic formation pattern: weathering, transportation, deposition, compaction, and cementation. All right? Those 5 processes that you've probably seen before in a science class are the 5 processes that work together to give us our most popular example of a sedimentary rock, detrital sedimentary rocks. So the first step, how do we get these clasts? How do we get these sediments? It's weathering. It's the physical forces on Earth's surface that break down large chunks of rock into small little rock fragments, or large chunks of mineral into little mineral fragments. Once weathering has taken place and given us those fragments, those foundational ingredients to create detrital sedimentary rocks, they're then transported by some of the same physical forces, wind, water, gravity, etc. Those little rock fragments, those sediments, those mineral fragments are then transported and gather in a certain location. We call that deposition. When sediments in clasts have been deposited, they typically gather and gather and gather and gather, and there's space in between the clasts as they are gathered in that area. We call that the pore space. Within that pore space lies some solution, typically minerals that have been dissolved in water, natural gas, or oil. Okay? So over time, you get more and more and more and more sediment deposited on top of sediment. So the sediment at the bottom has a lot of weight above it. That's when we have compaction take place. So naturally, those clasts are squeezed together tighter and tighter and tighter. The pore space is becoming smaller and smaller and smaller as you get more and more and more and more and more stacked above it. Once compaction is taking place, cementation takes over. As the minerals that have been dissolved in that solution that's floating between those clasts start to crystallize because the actual liquid is being squeezed out. Okay? Kind of like the wringing of a towel. You wring that towel together, you compact that towel together, you squeeze the liquid out of it. It's kind of what's happening towards the bottom of sediment layers and a large area of deposition. Okay? Your final product you get over time, a sedimentary rock. A rock that has been formed from the consolidation of clasts, sediments, rock fragments, and mineral fragments. Okay? Detrital sedimentary rocks, the first type and the first formation pattern that we're going to look at here. Now, how do you classify and identify these detrital sedimentary rocks from each other? A couple of things. Note that from lesson 1 we talked about composition and texture. We're going to use the same things here for lesson 3, all right, when we're looking at sedimentary rocks. Now, sedimentary rocks form from clasts, so we're going to look at the size of the clast. Gravel, sand, silt, or mud or clay. Okay? So you're going to examine the actual size of the rock fragments and mineral fragments that are making up that detrital sedimentary rock. That's the first thing you're going to do in order to identify or classify a detrital sedimentary rock. Next thing, you're going to look at the texture. What's the size, shape, and arrangement of those clasts? Once you've established that, you want to know the composition. What are the clasts made of? What type of rock or mineral? And then, what's the mineral that's present that's holding them together? All right? So 3 things, I guess, we could finalize here, officialize in regards to the classification and identifying of detrital sedimentary rocks. Looking at class size, you're looking at class and mineral composition, and you're looking at the type of mineral that has been used to actually hold those clasts together. That does it for detrital sedimentary rocks. You should feel a little comfortable now about what a detrital sedimentary rock is, how it forms, and how we classify them. Moving on, chemical sedimentary rocks and biochemical sedimentary rocks. Chemical sedimentary rocks we like to call evaporates. Now what happens with the formation of a chemical sedimentary rock is really similar to the formation of some minerals, okay, that we studied back in lesson 1. What happens is we get these little chunks of rock and mineral that have been broken down so much that they are actually completely dissolved in aqueous solution inside of water, okay? So we either get a lot of those minerals and rock fragments present in that solution where it becomes super saturated, or the water starts to evaporate out and we get a solution that's super saturated. Regardless of either one of those little processes there, what is the outcome is what we call an evaporate. So if we got ourselves a solution that has dissolved rock and mineral fragments in it, and over time the water leaves, what's left behind is a crystallization of the mineral and rock fragments, giving us a chemical sedimentary rock. And a prime example of that is rock salt, which is one of the sedimentary rocks that we will identify and learn about in class. And it's also a little bit of process that we're going to model inside of class with a little activity. Okay? So chemical sedimentary rocks form from the evaporation of an aqueous solution, all right, the liquid inside of a solution, and the remaining material is then crystallized, held together, and gives us what we call a chemical sedimentary rock. Biochemical sedimentary rocks form from the remains of living organisms. The process that forms a biochemical sedimentary rock is really similar to that of a detrital sedimentary rock. It's just that the class that we're talking about, the sediments that are actually held together at the very end due to cementation, are the remains of living organisms. Two classic examples of biochemical sedimentary rocks would be limestone and coal. Limestone being the remains of living organisms that have settled down towards the ocean floor, layers upon layers upon layers, compaction, and then cementation, with the mineral that is doing the cementing being calcite or calcium carbonate, giving limestone a very, very unique composition in regards to other sedimentary rocks. The class are living organisms, and it's got a specific mineral that is actually holding those little remains of living organisms together, calcite or calcium carbonate. Coal, on the other hand, is dead organic matter, carbon-based organic matter that is decomposing and decaying. Typically comes from a substance that we call peat, which is a lot of plant material that has been gathered in some type of swamp, bog, or tropical area. Well, over time, you get layer and layer of peat stacked on layer and layer of peat. And the amount of oxygen that's needed to continue the decomposition and decaying process is not present. So it kind of goes into a hibernation state. So that plant material doesn't get completely broken down, but it gets further and further and further and further buried underneath Earth's surface, which means it gets heated and heated and heated more and compacted and compacted and compacted more. And over time, you get this really nice, pure carbon substance that can then crystallize and bond together, all right? Come together, and that substance is coal. Okay, that does it for lesson 3 here, sedimentary rocks. After watching this video, I know it's a lot of information. You may need to watch it again. You should feel more comfortable about the definition of a sedimentary rock and where it fits into our overarching definition of a rock, all right? And you should feel more comfortable about the 3 types of sedimentary rocks. Just like igneous rocks, we really differentiate these 3 types of sedimentary rocks on how they form and where they form. Okay? So to know about a detrital sedimentary rock, you need to know about how it forms, where they form, and how we classify and identify them. Okay? To know about a biochemical sedimentary rock and a chemical sedimentary rock, know how they form. All right. If you want to be able to identify and classify them, tell the difference between sedimentary rocks from other sedimentary rocks and other rocks in general, you need to know how they form, where they form, and what they form from. All right. Make sure you brush up on that information. Textbook reading 824 to 829. Definitely take a look at that stuff. You know you need to have the Section 3 directed reading guide done with this lesson as well. If you have any questions, feel free to contact me. Do not hesitate to contact me. Email me, text me, call me, tweet me, something along those lines. And I'll see you guys in class. Thanks for tuning in.